Alright, hi everyone. Let's continue with our data structures and algorithm series. And today we are going to implement another important method in linked list, and that is insert method. This method works by adding a node to the linked list at a specific position. For example, this is my given linked list and we have to add a node that has value 0 at index 2. Now if I iterate over this linked list, then currently we have node 7 at index 2, right? Now to add 0 at index 2, we have to make sure that the node at index 1 points to this new node that has value 0 instead of directly pointing to node 7. And this new node will point to node 7. In this way, we will be able to insert a new node at the given index. As you can see here at index 2, now we have node 0, and the previous node that was at index 2 is now at index 3, and that's how insert method works. Alright, now let's look at the pseudocode of insert method and try to implement it in JavaScript. So the insert method will accept two parameters. One will be the value, which is the new node, and the other one is index number, where we have to place our new node. Let's create this insert method in our singly linked list class. This is our singly linked list that we created in our previous videos, and we will create our insert method here. This will accept value and index. The first step is, if index is smaller than 0 or greater than the length of linked list, then return false. Alright, let's add this if condition. If index is smaller than 0 or index is greater than this dot length, which is the length of linked list, then return false. The next step is, if index is same as the length, then use the push method. Alright, so if index is same as the length of our linked list, then we will call our push method that we implemented in our previous video. You can check out that one in case you haven't checked it out and want to see how exactly push method works. And here we will pass our value. What exactly this push method does is it makes the tail node to point to the new node and make this new node as the new tail, basically adding a new node at the end of linked list. Next step is, if index is 0, then make the new node as the new head, and this new head will point to the given singly linked list. Now this process is also called unshift. You must have seen this in arrays, where you add new element at 0th index. Same thing we will implement in our linked list. Let's implement this unshift method first, and then we will use it. For unshift method, I will create a function here. This unshift method will accept a value that will be the value of our new node, right? Let's create a new node now. Let new node equals to new. We have a node class already created here in our previous videos, if you remember. If not, then you can check out. We will pass this value here. Now if let's say there are no nodes in our linked list, if not this dot head, it means we have no nodes in our linked list right now. Then what we will do, we will assign this dot head equals our new node, and this dot tail will also point to this dot head. Same thing we did in our push method, right? And now let's say we already have few nodes in our linked list, then we will create a else statement here. Else new node dot next equals to this dot head. What exactly we are doing here is, now new node will point to the given singly linked list, and then we will make this new node as our head. So this dot head equals to new node, and that's how your new node will be inserted at 0th index. After that, we can simply return the modified singly linked list. Return this. Cool. Now coming back to our insert method, the pseudocode was, if index is 0, then call the unshift method. Let's write another if condition here. If index is 0, then we will return this dot unshift. We will pass the value. This will insert the new node at the 0th index. Now let's look at the next step. Now after handling all the basic cases where either we were adding the node at 0th index or adding the node at the end of the linked list, now we have case where we might need to add new node in the middle of the linked list. For that, what we need to do is access the node at index -1. The same thing which we saw here in our visual example, like where we need to add the node 0 at index 2. For that, we accessed the node at index 1, which is index -1, right? Now same thing we have to implement here, and after that set the next property on that node to be the new node. Same thing which we handled here, where node 5 is now pointing to the new node, and set the next property on the new node to be the old next, meaning this new node will point to the node which was actually present at that index before adding the new node, so the chain doesn't break and rest of the linked list remain unchanged. And for accessing the node at index -1, we will use our get method, which we implemented in our previous videos. Let's implement this step. Now first of all, we have to create a new node, right? We are accepting a value as a parameter in our insert method. For that, I will create a variable here called let new node equals to new and our node class. Then we have to pass the value in it. Now this will generate a new node for us. After that, we have to access the node at index -1 position, right? So for that, I will create a variable here, let previous equals to this dot get. You can check our get method video to understand how exactly it works. And here we will pass index -1. And now after getting the previous node, we have to store the reference to this part of our linked list, so that later on our new node can have the reference to this part of the linked list. For that, I will store the reference. I will call the variable name as temp and then previous dot next. Now we will add reference to our new node into the previous node. So previous dot next will be equals to our new node, and then this new node will point to the rest of the singly linked list that we saved in our temp variable. And after this, the next step is increment the length. Since we are adding a new node in our linked list, it will increase the length of the list. So we will do this dot length plus plus, and in the end we will simply return true. That will indicate that new node is already inserted. Now before running this code into the console, one more thing I would like to mention. Since we are returning booleans, in the end you can see we are returning true. In the first condition we are also returning false, but in these two conditions we are actually returning the whole linked list. Let's convert them also in boolean values. For that, I will just use this syntax of JavaScript to convert them into booleans. Cool. Let's try to run this and see if it is working as expected or not. I will open my console. Now we already have a linked list here which has nodes 1, 2, 9 and 10. Now let's try to insert list dot insert 0 at index 1, which means at the place of 2 we will have 0, and 0 will point to node 2. And after inserting, let's console log our list. Alright, you can see we have now 5 items in our linked list, where the first node is 1 expected, which is pointing to now 0, which means our insert method is working fine. We have successfully inserted 0 at index 1, and this 0 is pointing to 2, which is great, expected, and 2 is pointing to 9, and so on. So our insert method is working as expected. Let's try to insert node 0 at index 0. As you can see, the head is now updated and node 0 is pointing to node 1. But there is one issue. If you see, the length is still 4 instead of 5, which means we forgot to increase the length of our linked list in this unshift method. Let's do this dot length plus plus, and after updating this, you can see the length is now showing 5, which is the correct length. That's all for this one, and thanks for watching.